All right, guys. Hello and welcome to the compositing workshop through UC Santa Cruz. Um, this is Intro to Compositing. I'm Dylan Gallup. Um, some of you may have already met me. I may know you. But if you don't, I'm an animator at Core Studio. And I've been working with After Effects professionally for about 3 years now. Mainly doing motion graphics work, but our studio does a lot of VFX stuff as well. And so I've learned quite a bit, and I'm here to share some of the theory behind compositing and what it is today. It's going to get a bit technical, so be prepared for some math and just, keep eyes and ears open here. And bear with me. Let's see. So we're going to start off with just the definition of compositing. Let's get our toes in the water. Compositing is just the combining of visual elements. We've all seen images like this one that I have here, where you have actors on a green screen and you're comparing, what it would look like when they were filming versus what the final product was. And this shot is, a very technical 3D rendering with a lot of, lighting work and technical direction. We're probably not going to be able to achieve something quite this good, but with a little bit of work, you can definitely get there. Okay. So we know that compositing is the combining of separate elements, right, into one image. But what does that mean? In After Effects, we are looking at each image, each element as a separate layer. And we have a nice little picture here to kind of help us imagine what that's like, right? The software basically says, okay, we have our smoke layer, we have our explosion layer, we have some additional particles, we have a 3D render, we have maybe some footage of the sky in this case. We're just going to take all of those and we're going to smash them together. Hopefully they look good, right? Where's the art in that, right? Those images are all coming from separate sources. Well, it's a much more difficult task than just slapping everything together. We have to understand how to combine these images in various ways using different techniques. And we're going to be talking about mattes, transparency, and blend modes in a minute. We need to make sure that we can tweak our color, right? So that the shot looks like one cohesive thing. And we can add additional elements, like a lot of lens flares are done in comp now. Cameras don't really make lens flares anymore. They're good enough so that they don't do that, but we still like them, so they get put in over the top. There may be some amount of elements generated in composite, usually not very much, but enough to kind of finish the product and make it that complete professional looking thing that you see. So it's important in any industry really where visual work is being done. An understanding of compositing is really what brings work from here to here. So I'm just going to keep rolling through here. I'll try to slow down a bit. I know I can be a little quick. We are going to dig into RGBA now. So when you're looking at a modern monitor, you're looking at, we all know we're looking at pixels, but those are comprised of 3 lights, right? We have a picture here that demonstrates you have your red, your blue, and your green lights. And those are on a scale from 0 to 1. The actual numbers underneath don't really matter to us that much, but for our purposes, we'll think of them from 0 to 1. So basically, you're telling your computer, hey, I want to light this individual pixel. Here's the color. Here's how you mix it. and then it mixes the light together as it shoots it out to give you the image that you want. We store that data in RGB channels. So an image has a data point for a pixel that says, okay, this is the red, this is the green, this is the blue, right? And that's important for compositors to know. You know, you may be thinking at this point, oh man, he's getting in the weeds. Like, this is way too technical. But having a really strong understanding of actually the math and the technical side is very important for a compositor, because you are that final bit of polish. All of this actually affects compositing a lot. So we've talked about RGB, but there's also the A channel. And the A channel is how we get our transparency. And there's a little bit of an example here in the bottom right, where you can see there's a transparent image, and the A channel looks like there's black where it's fully transparent, there's gray where it's partially, and there's white when it's fully opaque. This A channel isn't in everything, but for transparent images, it's necessary, because that's how the computer knows, oh, this is how I combine this image with another one, right? When we're talking about actually working with the file, there are several different ways to store that color information. There's 8-bit images, 16-bit images, and 32-bit images. You could theoretically have more than that, but those are the common numbers. Occasionally you'll run into something that has 10. But what that means is basically this pixel can tell you to a certain level of precision what its value is, right? So 8-bit is the most basic. That is actually typically what we see, right? When we're looking at our monitors and we're looking at a video or anything, we're going to be looking at 8-bit information. There's no reason to have more than that amount, because that's what's displayed. So the only reason we need those 16-bit and 32-bit images are for compositing, because you know, when we are rendering, when we're outputting our final product, you know, it's going to be 8-bit, but while we're applying things like lens flares, lighting effects, we're doing color correction, we want to have the bandwidth, you know, the additional amount of padding to be able to control those images a lot more, and get some more fine-tuned stuff. Higher bit images are often called high dynamic range images, and you maybe have heard about the new TVs and monitors that are in high dynamic range, and those are 10-bit. And basically that's creating a monitor that lets you use some of this higher information that compositors are already using, and make a better quality image that has more of that lighting depth, more of that color depth, you know, because we humans can see actually more color than our monitors can put out right now. So when you're thinking about HDR, you should think about color correction, right? You have more control over that, and you should think about lighting. So a good thing to think about for high bit images is a picture of a light bulb, right? In a normal picture, if you took a picture of a light bulb, what you would see is just pure white, right? The sensor in your camera can't handle all of that information. If you're able to take a high dynamic range image, then you can actually color correct that, and you will see inside of it the actual filament on the bulb, all of that information. So when you're looking online and you're trying to find resources to maybe put into your comp, and you need to maybe color correct something or have some of that more dynamic dynamic range so that you can get the right color and you can get the right look, you should pay attention to what the bit range of the file is. So with that in mind, let's talk a little bit about file formats, right? We all know the JPEG, or we should. That is an 8-bit image. That's final output. You know, think of that as you have very small files, they're compressed, and we have a nice little image here of the compression of that file in the corner. Looks terrible, but that's way zoomed in or hyper compressed, you know, which you don't want to do. Don't output images that look like that. But it does let you have really, really small file sizes. And, you know, especially in the early days of the internet when everything was really slow, this was super, super important because you would, you know, spend hours trying to get just 1 or 2 pictures to load up on your computer. So every amount of, you know, file size was just precious. And even today, there's still good reasons for using JPEGs in that way, because let's say you have an image sequence, you know, you've rendered your project to an image sequence and it's, you know, 8,000 frames. Every additional amount of information adds up. If you want to package that and send it off to a client, to a friend, you know, you're transmitting that data, it's going to be way, way heavier if you use one of these other high-end things. Okay, so I'm going to go through the rest of these a little bit faster. But PNGs are basically JPEGs, but they have an alpha channel. So you'll see these a lot around. Portable network graphic is what it stands for. It lets you just, you know, slap an image wherever, and it has an alpha channel. It can figure out how to lay it transparently on something, right? JPEGs can't do that. TIFFs we use a lot in my company, 8 or 16-bit, and those have alpha, but again, they can do 16-bit, they can do high dynamic range. So those can be used, for example, we might kick out TIFFs if we want to do color correction in Premiere or After Effects, right? We'll render out a 3D model and we'll do it in 16-bit TIFFs. And then once we bring it in, then we have that additional range that I was talking about, right? We have more control. There's more color depth. There's more light depth. There's more depth to the image. There's more for the compositor to work with, the compositor to work with. EXRs are amazing. 32-bit RGBA plus. You can include more channels if you want. Maps, depth maps, you know, a lot of that stuff comes out of 3D programs like Blender. Blender could export EXRs, and you can have different passes in there, which are very useful as a compositor. Like a depth map, you can have a black and white image that just shows you how far away from the camera everything is. And that can be used to add fake bokeh. It can be used to add fake volumetrics, you know, like you're trying to do an underwater kind of thing. Super, super useful. EXRs, we use them all the time at work. They're surprisingly small for what they are. In fact, counterintuitively, sometimes EXRs can be smaller than TIFFs, even though they're 32-bit. So they store more data, but they can be smaller. Honestly, I have no idea how they do it. It seems like wizardry to me, but that's a great file format to know. Now, I'm going to go into the videos here, and you should know that at my work, we don't actually use videos very much other than for output. We don't do a ton of editing. We do it from time to time, but for the most part, we're doing digital elements, and digital elements are much friendlier to work with in image sequence formats. And so, you know, take this with a grain of salt. This is what we use when we do use video. Prob may be able to give a little bit more info here on some good formats. Maybe I'll ask him if he can put something in the Slack later. But most important one to know probably is just MP4. Again, it's like the JPEG. It's small. It's great to send to people. Kind of for the internet, it tends to be the final output for a lot of things. That's probably what you're watching on YouTube most of the time. If you are posting your work to the Slack channel for Prab and I to take a look at, please post MP4s because it'll be quicker for us to download and be able to take a look at. MOV files and QuickTimes can take a long time to load and be very heavy. So going into the QuickTimes, MOV formats, the two recordings that I use at work most often are ProRes 4444, which is basically high quality, low compression video with an alpha channel. So if you're doing any, not necessarily compositing, I suppose this is compositing, but more basic, just you need to overlay a little bit of video over another piece of video. All of the color work is maybe done already, or you have just minor tweaks to make. You can put those together in Premiere. This can be useful if, for example, you have a video element that you're going to change a lot and the rest of the footage is staying very stable. You can use this 4444 format to just separate out that piece, so you're only revising that one little section of video. 422, just the same thing, no alpha channel. That's kind of what we would output if we're going to put something into an edit. So I would recommend that if you're going into Premiere and stringing together an edit. 422s are nice. Okay. Let's see. Okay, I'm going to talk about combining images now. So this is all math. We're gonna get really into the math here in a minute. And basically, you have all these different blend mode options in After Effects and in every compositor, really. And they can be super confusing when you first take a look at it. You're like, what is this? Normal, multiply, screen, overlay, soft light, hard light. What does that mean? And I have an image here that shows you, some sort of examples. You can look online or do your own experiments with these, but really the ones that we use the most often, at least in my work, are multiply and add. And again, these are just math. Multiply and add are named for the math. You just multiply the values of one image times another, or you just add the value of that image to the other one. The other names that we see here are named from, back when people would go into dark rooms and do treatments to actual photographs. So some of them have weird names like color burn, color dodge. Those were all terms used back when you would do things, with chemicals, and they're sort of holdovers. These effects were named because they kind of look like treatments that people would do. So those are kind of interesting. You might enjoy looking those up and reading a little bit about it. All right, let's dig in to these blend modes. So here's an example. We have the top row here is a multiplication example, right? Or no, this is an add on the top. Basically, I have an image here that we have 1 is white, 0.5 is mid-gray, right? And then 0 is black. And we have the output of, once we add that to a 1 and 0 black and white image. The interesting thing to note here is that in the add, we actually have in this final composite values above 1, right? one is white. So if we look on this, this first output, what we see is that, I don't know if you can see my cursor, but what we see is that when the white is added to the white, 1 + 1 = 2, right? We all know that. But it just shows up as white to us. Underneath the hood, the computer knows that it's 2. And again, if we put color correction on this image and we tweaked it down and darkened it, we would actually start to see the rings emerge, right? Because the real values there are greater than white. They're bigger than 1. So that's where, you know, working in those high bit rates come in handy. And now multiply, similar thing, where if you multiply by 0, you get 0. So everything's black on the right hand side, and on the left hand side, everything is just exactly as it was, multiplied by 1, staying the same. These can be really useful in compositing in various ways. Add is used a ton in like if you've ever seen, I'm sure you've seen something like Iron Man, right? Iron Man, whenever he has all those overlays over his face, like he's in the helmet, and you see like all those little like graphics of all the motion graphics, those are probably all added onto the footage because it gives that kind of glowy light effect, right? There's like, it's getting added on top, like light gets added. Multiply is a bit of a rarer use case, but it can be useful as well. You'll see these blend modes definitely referenced if you watch tutorial videos about compositing. People are going to bring them up. So now that we understand how multiply and add work, I'm sure you've known how they work since you were young, but now we know how to apply them to our images. We could talk a little bit about alpha channel and transparency. So when we are actually compositing 2 images together, when the computer's doing that for us, this is what it's doing. It takes our A channel, our alpha channel, and it multiplies it by both the source image and the destination image in straight alpha compositing, which I have this graphic here on the left. If you look at, you know, the source alpha, you can see that where it's multiplied by the original image, it is black, right? It's black in the top right corner of the square, and it's fully red in the bottom left. The destination image is multiplied by the inverse, right? So it's black where it's multiplied by 1 flipped to 0. Kind of confusing, but basically we multiply, and then we multiply the inverse, and then we add. And in doing that, we get this nice composite image of like a transparent, you know, triangle, or no, it's not a triangle, it's a square. Transparent square laid over this woman's face. So that's how it's working under the hood. Everything is kind of based off of this basic math. If you look at this, it's important to note that there's a difference between straight and pre-multiplied images. You might see both of these in your work. You know, you can download an image. It could be straight, could be pre-multiplied. After Effects is very good at detecting which one it is. So it's nice in that way. It'll give you a recommendation, but it may ask you, is this straight or is this pre-multiplied? And all it means is if it's pre-multiplied, that first step of multiplying the source image by the alpha has already been done. That's all it means. So make sure you know what you're working with, because if you assign them the wrong thing, either that first multiplication won't be done and the resulting image will look wrong, or it'll be done twice And again, it won't look right. So that's it for now. I know that was sort of complicated. Hopefully you were able to, sink your teeth a little bit into that and wrap your head around the idea that it's all math. What we're really doing is we're figuring out ways to take this data and wrangle it together and stir it up and then get the image that we want out of it. Because once you understand that, you know that there are certain things that you can do with images and there are things that you can't do. Hopefully understanding some of this background will help you feel more comfortable, jumping into it and knowing what's going on. Thanks for watching. Please, if you have any questions, let me know on the Slack. We're going to be going into the practical applications of some of this stuff next. I'm going to do After Effects demos for you guys. I know you're eager to jump in. If you don't have the ability to access After Effects, I hope that watching me do it and understanding some of the theory will help you when you do have that opportunity. Thanks.